Okay, there's the start. So today this is more review, right, of solving equations. We will solve equations in this class. In every chapter, new kind of function, new kind of equations. We learn different methods. This is a review of the solving equations you should have already done in Algebra 1. And, there's a fair amount of solving equations that you do in geometry, too. But certainly, Algebra 1 is where you were supposed to have gotten this at least once. So we learned to solve equations. Pretty easy objective to understand. But we also learned to solve what's called a literal equation. And a literal equation means it has more than one variable. Right? So when more than one variable, when you solve it, it's going to be solving one variable in terms of another. Give you an example. This is a formula that you get in chemistry. And because most of you guys are young, you haven't had chemistry yet, it might be Greek to you, right? But PV equals nRT. Right? That's an equation called the ideal gas law. It tells you how, for a particular gas, the pressure and the volume and the amount of the gas and the temperature all relate. Okay? Because my background was in meteorology, when you study the atmosphere, you realize the atmosphere is a gas. So it obeys this ideal gas law also. Now, if I wanted to solve for any one of those, that would be solving a literal equation. Right? Solve for the pressure, divide by V. Solve for the temperature, divide by NR. Another thing that I always assume that coming out of Algebra 1, you should know pretty much about variables. You should know about how to solve equations. And what was the other one? And you should know most of the things about linear functions. Right? And we will review linear in the next chapter. But give an example like this. 2x plus 3y equals 6. That's a linear equation. That's what we call the standard form of a linear equation. What is it that makes it linear? Say again? Well, just looking at the equation, it's true that its graph will be a straight line. But how can you tell by looking at the equation? Because x and y are raised to the first power. That's what makes it linear. Now, that's probably not the form of the equation that you remember, right? You remember y equals mx plus b. So if you want to have it in that form, you've got to solve that for y. Okay, that's solving a literal equation. Another thing you were supposed to have, which my guess is you probably either didn't have or didn't have it very much, and you might not remember it at all, certainly probably never came up in geometry, was systems of equations. Does anybody remember doing systems of equations? What is a system? You remember the word, but you don't remember what it was about. Does anybody remember what's a system of equations? A system of equations means more than one equation. And then you have to solve it. And when you did it in Algebra 1, the equations were definitely linear. And if you remember anything about it, they can intersect at a point, they can be parallel, or they can be the same line. Do you remember that now? Yeah. Kind of, sort of? Yeah. Okay. In this class, for this SOL also, we do nonlinear systems. So we're going to do things that the graphs are not straight lines, things like a circle and a straight line. Find the intersection points. If you want to, this is an example of equation of a circle. X squared plus y squared equals 4. If you wanted to solve the system by graphing, by putting in the calculator, you would first need to solve that for y. Subtract x squared, take the square root of both sides. But there's another example of a literal equation. I mean, that's why we do this. How do you solve literal equations? Do you ask a question, Kareem, or just? We will use y equals mx plus b, definitely. Okay. So that's our two objectives. Plain old equations, literal equations. Okay, but how do you solve equations? Well, up to this point, you solve equations by isolating the variable on one side, the answer will be on the other side. Okay, how do you isolate? If the variable is not already isolated, if it's not alone, then what are you going to do to make it a loan? Yeah, in this case, you would subtract 4. In effect, what you're going to do is you are going to apply one of what they call the properties of equality. Subtracting 4 from both sides here, x equals negative 16, that's called the subtraction property of equality. That if you have an equation, you know that what's on the left equals what's on the right, you are allowed to subtract the same thing for both sides. So mostly we don't think of it like that. We're not thinking properties in our head, but that is what you're applying. Are you okay? Are you okay? Okay. Okay, that's a one-step equation, right? You only had to do one thing, done. Okay. Are we done with that? Yeah. Yeah. We're going to do that next. Are we good now? Okay, good. And these are the other properties of equality, right? This is the one that we just did, right? Subtraction property of equality. What do you think you're going to call it if you add the same thing to both sides? The addition property of equality. What do you think you'll call it if you multiply the same thing to both sides? Multiplication property of equality. And if you divide this both sides by the same thing, right? That would be the division property of equality. They're almost kind of silly things to have a name for, really, but they do show up. They show up in the book. They show up on that one properties question that we will get on the SOL, definitely. We done now? Here's a summary of the properties of equality, at least these. Whatever you do to one side, you got to do to the other side. And it's actually not just add, subtract, multiply, divide. You can square both sides. You can take the square root of both sides. You could flip both sides. Just whatever you do to one side, you got to do to the other. As long as you do, everything's still good. Still an equation. The left still equals the right. John? I can't hear you. Sure. Okay. Now there are some more properties, right? These are the others. Some of them which seem like when would you ever use that, but they are properties. They're in your book. The first one, and I should be clear that these are not minus signs. These are like bullets, right? A equals A. A number equals itself. Sounds kind of silly to be a property, but it is. That's called reflexive. Anything equals itself. The next one is, and I always confuse myself, the first two, which is reflexive and which is symmetric. Symmetric is if you have an equation, you can flip the sides. it's still the same equation. I mean, I do that a lot when I'm solving an equation. If I end up solving for the variable on the right and I'd kind of like to have it on the left, then I just switch the sides so that it ends up being x equals something. And you can do that. It does not change anything. The transitive property, if A equals B and B equals C, then it must be that A equals C, right? Because they both equal the same number, B. That's called transitive. I still have that up there. Okay. And then the last one, which they use a lot, it's called substitution property, which we've done at least twice so far already in the homework today. Like right here, when I said -3 plus 7, I replaced it with a 7. That was substitution. Since they're equal to the same thing, you can substitute one for the other. In a way, if you look at these last two, they're kind of like saying the same thing. You know, if A equals B and B equals C, well, then I can substitute for the B, C. So is that a substitution property or a transitive property? It's really the same thing. Okay. All right, we'll get to solving a lot of equations here in a second. Good. So now we're going to solve multi-step, right? We don't just go like one step, two step. It just goes one step, multi-step. If it takes more than one step, it's multi-step. So the first thing we're going to do is if you see on one side of the equal sign that there's some like terms to combine, you should combine them. Right, check both sides. Make sure there's no terms that you combine that are on the same side. Because the next step, you're going to start moving things side to side. But don't start moving things side to side if you haven't simplified completely what's on each side. Then start moving terms. So simplify each side, and then we expect that we will have some terms that have variables, some terms that don't. Do you remember what we call a term that doesn't have a variable? A constant, right? So we're going to have to deal with variable terms and constant terms. Generally, we deal with the variable terms first. You know, you're not wrong if you don't do it that way, but generally speaking, we say deal with the variable terms first and move the smaller of the two variable terms in order to get them both on the same side. Meaning, whichever one has the smallest coefficient, then move that term to the other side. Then you'll still need to get the constant terms on the other side because they're going to make up the answer. So move the variable terms, move the constant terms. At that point, there still may be one step to take. Probably be a division to do, to solve. It'll be a one-step process. Okay. Curtis, about done? Anybody else? John? Are you good? Okay. Okay. So this example here, is there any combining of like terms we need to do on the same side of the equal sign? Are there any like terms to take care of on one side of the equal sign? No. So we can go to the next step, which is move the variable terms. Which is the smaller coefficient of those two variable terms? The 3w, right? So how can we move that term or cancel it from the side? Subtract it, right? So minus 3w minus 3w. So that's 4w plus 2 equals 94. Okay, now we need to get the constants to the other side. Minus 2. Okay, now we're left with a one-step problem, which is divide by 4. You good? Sandy? You good? Anybody else? Okay, how about this one? Any simplifying to do on either side of the equal sign? Kareem, distribute, right? So we need to distribute on the right. Negative 27 plus 6y equals 3y minus 9. Okay, which is the smaller coefficient of the two variable terms? The 3y. Right? Don't worry, it's going to get harder. Okay, get the constants onto the other side. Add 27. Last step, one step, divide by 3. Okay. Are we done, Natalie? Okay, try to solve that one. Sorry. Yeah, of course. Yeah, if you didn't grab your calculator, go ahead, grab your calculator. Remember, when you come in here, you know which one is yours. If you don't remember, I can tell you. But when you come in, grab the calculator. So who's got an answer? Where's that? Here? Nope. Yes. 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 Did you get it, Morgan? Let me see. Okay. Good job. Shayna, you get it? Let me see. Good job. No. What did you do right here? How did you go from this step to this step? You should have added 3D to both sides, because that's the smaller. That would have given you 4D on that side. Okay? How are we doing? Good. 30. So somehow that shouldn't have been a 2. So we have, most of you are getting it correct. What was the first thing you had to do on this? Move the variable terms. Which is the smaller of the two? I mean, remember on a number line, whatever's to the left is smaller than whatever's on the right. -3 would be the left of the 1, the positive 1. So this is the one you'd want to move. Now, if you don't do that, you can still get it right. So it's not like you're wrong because you subtract d. You would just end up with a -4d. Everything would be negative, which is fine, except when you get to inequalities, then you know because of the negative coefficient, you're going to end up flipping inequality signs in that. That's why we try to keep them the coefficients positive. So how do I cancel this -3d on the left? I add 3d, right, plus 3d on both sides. So 43 equals 4d plus 9. Right, then move the constants to the other side. Right, so -9, -9. 34 equals 4d. Divide by 4. So that gives us d equals 34 over 4, which you can simplify. That's 17 over 2, or you could turn it into a decimal. That's 8.5. Now, what property of equality did I just use when I went from this to this? Take it? The symmetric property, right? I had the d on the right side, and I flipped it to make it on the left. We do it just automatically, but that's symmetric property. Okay. Okay, here's a word problem, since you guys are a smart class. Okay. And I'm showing you a word problem that's pretty close to a word problem that'll be in the homework. So I'm not asking you to do one you've never seen before. It's pretty close to the same thing. Right? 2 buses leave Houston at the same time and travel in opposite directions. One averages 55 miles per hour. The other averages 45 miles per hour. When will they be 400 miles apart? Okay, so a lot of times, what's a good way to start a problem like that? Well, point of the variable, what is it that we don't know? What is it that we don't know? When, right? So the thing that we don't know is the time. The variable is going to be time. T equals time is what we're solving for. Okay. Now, sometimes it helps to draw a picture, right? So if I draw a picture, I'm going to say in the middle of my picture is Houston. And they're saying one bus is going this way, traveling 55 miles per hour. And the other bus is going this way, and it's going 45 miles per hour. Okay, we're trying to find when is the time that that distance is 400. They're driving in opposite directions. Well, let's see. What these 55 miles an hour, 45 miles an hour, those are speeds, right? So what's the relationship between speed and distance and time? Shisa? Rate times time equals distance, or you could think of it like this: speed equals distance traveled per time. Shiza said rate times time equals distance. Same thing. So she's saying in place of speed, she's using the word rate, right? And then if you multiplied the time up here, you would have rate times time equals distance. Okay, well, let's see. In 1 hour, how far apart are these two buses? Well, that would have gone 55 miles that way and 45 miles an hour that way, right? So that would have been 100. What about in 2 hours? They'd be 200 miles apart, right? You can kind of figure out this one. In 3 hours, they'd be 300. In 4 hours, that would be 400, but they left at the same time, so 4 hours later. I'm not sure if the problem actually said they left at noon. I don't think it did. But generally, we want to say that the distance, the first distance plus the second distance equals 400. Right? The first distance would be 55 miles per hour times the time, plus the second distance will be 45 miles an hour times the time, and all of that adds up to 400. So that's turning the problem into an algebra problem that you can solve. Right? How can I simplify the left? Add them up. What's 55t plus 45t? 100t equals 400. And then to solve for t, you divide by 4. Or divide by 100, sorry. So t equals 4 hours. So we were given a problem, we modeled it with some math, we solved the math, and then we turned it back into our, word, Rate times time is distance is another way to say that speed equals distance over time. Same thing. This is what a physics person's going to say. Shiz is a physics person. Okay. Like I said, there is one problem, the 27. This is actually number 26. The 27, I think, is about airplanes, but it's basically the same kind of thing. You need to know this relationship to solve it. I know you can do it. That's why I'm giving it to you. Okay, let's see. Try to solve that one. Are you running into any trouble? Yes. Okay. To be expected. Okay. There's a reason why I gave you this problem. What are you seeing on the paper? Okay. Anybody else? What did you get? What do you come down to? 4 equals 6, right? So let's see. If you first of all, what would be the first step in solving this? Combine like terms on each side of the equal sign, right? So 7x minus 4x is 3x. Okay. What, I'm not understanding here. Okay. Well, let us keep going here. What's 12 minus 8? So that's 3x plus 4. Okay, then we say, okay, take care of the variable terms. Well, they're the same variable terms. So when you subtract 3x, what happens? You get 6 equals 4. Now, 2 things about that. Number 1, there's no variable involved, which means the answer does not depend on the variable. The second thing is, that's a false statement. That tells you that regardless of the value of the variable, this thing has no solutions. There's nothing you could have plugged in here to make the left-hand side equal the right-hand side. No solutions, because that's false, right? This is false. Right? Therefore, no solutions. And that can happen. It will happen. Right? It'll happen in the solving of different kinds of equations along the way, that you end up with an answer that has no variable and is a false statement. Yeah. It doesn't matter. You still got a false statement, right? You had no variable and a false statement. Okay, that's good. Okay. So the counterpart to that would be this. How would I start simplifying that? Distribute. Okay, and then combine like terms on both sides, right? So this 2x plus 3x. (4x plus x). Now, at any point now, you could pretty much see what's going to happen. If you want to take that next step of subtracting the variable terms, what's going to happen? Negative 12 equals negative 12. Yeah, again, 2 things. There's no variable, so the answer does not depend on the variable. Second, that's a true statement. That means this one's going to be true no matter what you plug in for x. The left will always equal the right. Okay? So that's true. So the solutions are all real numbers. Yeah.
Real numbers are only like 1, 2, 3, and above.
No, those are whole natural numbers. Remember, the real numbers are all the rational numbers, meaning fractions, decimals that terminate, decimals that repeat, plus the irrational numbers like pi and the square root of 2 and all that. Put them all together, real numbers. Okay. We good? Rebecca? You done, Rebecca? Not hearing me. Okay. So here's the 3, and you have a couple of problems like this in the homework. So I want to let you know. The way that they're wording this is like this. If you solve an equation and you get an answer, like we did 17 halves, 8.5, like that one we solved and we got one answer. You would say that that equation is sometimes true. It's true when the value is exactly this one thing. It's sometimes true. That's actually called a conditional statement, or a conditional equation, because it's sometimes true. Depends on the conditions, depends on the variable. If you solve an equation and there is no solution, then in the book they're looking for you to say, that means it's never true. Okay. If you solve it and you get all real numbers as a solution, then they want you to say it's always true. And that is called an identity. When an equation is true, no matter what the value of the variables, that's called an identity. It means one side is identical to the other. It may not look like it when you start, but it's the same thing. You'll see next year in trigonometry, we spend a lot of time verifying trigonometric identities. John? Okay. So I just want, for the homework, because I think there may be like 2 problems that you have this. Just remember, sometimes true means you get an answer. Never true means no answers. Always true means the solution's all real numbers. These words, I'm just telling you. You know, it's a conditional statement if it's only sometimes true. It's an identity if it's always true. Yeah. There'll be a video and there will be notes. And the video will have the voice, everything. You can hear you can hear me. Right. We ready? Okay. Now we get to the point about literal equations. Right? Literal equations are equations with more than one variable. And they got to tell you which one you're solving for. So this first set of problems, actually, these are formulas. So this is a solve for G. Okay, well, you see the G? It's in the middle of the right side. It's not alone. So to solve it, we need to do properties of equality in order to isolate it. Okay, what are we going to do to isolate this G? What's that? Say again? Well, you know, what's the operation between the G and the T squared? It's a multiply, right? So how do you get rid of a multiply? You divide. So in one step, you could do this. Divide by T squared. Divide by T squared. Now we've got 1/2 G equals S over T squared. Okay, then, yeah. Okay, so we're saying multiply both sides by 2. How many we're going to say divide by 1/2? Okay, same thing. Dividing by 1/2 is the same thing as multiplying by 2. I would definitely recommend multiply by 2. Because here's what happens if you don't. If you divide by 1/2, then at the next step, right, you got to figure out how is it that you divide by a fraction. dividing by a fraction is the same thing as multiplying by the reciprocal. So you would turn this into s over t squared times 2 over 1, which in effect there you are, you're multiplying times 2. So if you do the route of dividing both sides by a half, eventually you will multiply by 2. I would think instead I would have just taken this at that step and multiplied both sides by 2. And what do you get? 2s over t squared. So if there's any confusion about this, quiet. When you multiply fractions together, how do you multiply fractions? You multiply the numerators and you multiply the denominators. Okay? You don't cross multiply. Good. Solve for x. Okay, what's with the x on the left-hand side that you have to get rid of? A and the minus 5. Which thing do you think you would do first? You're not going to divide by a. It's already divided by a. Multiply by a? How many say multiply by a? How many would add 5? The right answer is probably to add 5, but you could be right if you do either one. Okay, but here's what I see when we do this. A lot of times, students will say, "Well, I'm going to multiply by a." Okay, so I'm going to write it like this: multiply times a, and then this is what their next line looks like. It says x minus 5 equals a times b, and that's wrong. Okay, say it again. Yeah, if you multiply by a, you have to multiply every term by a. So most of the time students forget they got to multiply the 5 by a also. So to be correct, it should have an a there. Okay, so if you take that route and you do it correctly, then you have one more step to solve. Plus 5a, right? Plus 5a. So now we have x equals ab plus 5a. So if we do it the other way, then we would add 5 to both sides. Right, now we have x over a equals b plus 5, and then multiply times a. X equals ab plus 5a. It's the same thing. As long as you're careful about it, you'll get the same answer for both. You okay, David? Okay, here's a more complicated one. Solve for capital R. It's actually a one-step problem, but where's the capital R? Right there. What do you think would be the right first step? Yeah, I mean, what's with the R that you need to get rid of? The R1 plus R2. right? And what's the operation in between the capital R and the sum of R1 plus R2? That's a multiply, right? So in one step, divide by R1 plus R2. Divide by R1 plus R2. Right? And then that cancels, and you're done. Now, if you said distribute, that's not like just another way to get the right answer. That would be wrong. Because what are you doing? You started with R in one place. If you distribute, you would have like spread it to two different terms. And the whole idea is to isolate it in one place. So you wouldn't want to distribute. That's going to put it into two terms, and you just want it in one term. So this just divide by the R1 plus R2. Done. Okay. One more example. We ready? I think everybody's getting tired. Solve for H. Okay, where do you see the H? What does this look like? That looks like what kind of a formula from geometry days? The surface area, because it's got 2 times pi r squared, that sounds like 2 circles, right? So it's probably a cylinder. Circle on the bottom, circle on the top, and then this 2 pi r would be the circumference of the circle. When you multiply that circle times the height, now you got the sides, right? So this is the bottom and the top, that's the sides. Does it matter? No, doesn't matter to what we're doing right here. How can I isolate the H? Okay, if you divide by 2 pi r, you're still going to have this term to deal with, right? Again, I would recommend first you subtract the 2 pi r squared. But you wouldn't be absolutely wrong. Your answer might look a little different, but we can do it both ways like we've been doing, right? Minus 2 pi r squared minus 2 pi r squared. Right, now we've got 2 pi r h equals s minus 2 pi r squared. So I did the symmetric property. Okay, there's our h. How do I isolate the h now? Divide by 2 pi r, right? So divide by 2 pi r. Divide by 2 pi r. Cancel, cancel. Oh, I just did that wrong. Meant to go cancel, cancel. And that would be an acceptable form of that. Now, if you did it the other way, let's say I divide by 2 pi r in the first step. Then the next thing it would have looked like is s over 2 pi r equals, what are you going to get when you divide 2 pi r squared by 2 pi r? Just an r, right? So that would be r plus h. And then what? Minus r, right? Minus r, minus r. So h equals s over 2 pi r minus r. Now again, does that look like the same thing? Does this look like this? No. Are they equivalent? Sure. You would have to find common denominator by multiplying this by 2 pi r over 2 pi r, and then it would look exactly the same. Most of the time, if you've got 2 terms and your variables in one term, I would get rid of the other term first, personally. But you could still be right if you do it a different way. Is that enough? You give up? That's what we did. That's the homework. I believe, I don't think I gave you that problem, did I? Let's see, 5, 30, 37. No, I didn't give him that one. Okay. So that is that.